Hello intellectuals, in our today's tutorial, this is Chemi lecture 4. Previously, we saw chemical reactions in solutions, some made of solids, which we were calling precipitates, other made gases, and other neutralized acids and bases. But there is also another huge category of reaction that power batteries, make metals last, and even keep us alive through breathing. So this kind of reaction is what we are calling to be what? Oxidation reactions. Oxidation to reduction reaction. When we these are commonly known as redox reaction. Redox reaction. So in this lecture we are going to talk about this into three parts. Our first part we are going to introduce redox reactions. Our second part we are going to practice questions on redox reaction, even those that we are going to recognize which of the reaction undergone reduction, which one was what was reduced. The last and the most interesting part, it is on balancing redox reaction. This lecture occupies a lot of marks in your exams. More especially, balancing redox reaction may carry each question 8 marks. And this also you find it on section A. Even on those questions in your test, you find the question. So this is also the very important lecture which you need to take seriously and pay attention. So a redox reaction, let's start. Let's start talk about redox reaction. So a redox reaction involves two reactions happening at the same time, which is a reduction and oxidation. So these two reactions happens at the same time. Okay, so what is oxidation? Oxidation is the loss of what? Of electrons by a substance. Loss of electrons. Then reduction, which is the opposite. Reduction now it's going to be the loss, the gain. This one is going to be the gain of electrons. So we know that when an electron, an atom loses electrons, it becomes positive. So this oxidation involves what? An increase in oxidation number. So let me talk about an oxidation number first. So an oxidation number, this is the number that is assigned to an atom to show what the degree of oxidation or reduction. So let me write it for somebody who may like the definition. So it can be defined as an oxidation number. Actually, say an oxidation number is a number assigned to an atom, or we say to an element, to show the degree of its oxidation, which we are calling electron loss or reduction. So if an element has lost 2 electrons, okay, for example, so it's going to be positive 2. because positive is showing that it has lost what? Electrons. If it has gained, it will be negative 2. So what we need to know again, oxidation involves what? An increase in oxidation number. So this one involves an increase in oxidation number. Here we have a decrease in oxidation number. Okay, so decrease in oxidation number represented by the negative, meaning it gained what? Some electrons were gained. If some electrons were lost, it's gonna be represented by what? By a positive. A number, it's just what? It's showing a degree. How many were gained or how many electrons were what? Were lost. So this is what you need to know about oxidation. Let me try to give an example. Let's give a reaction between zinc metal and copper 2 ion. Producing zinc ion and copper metal. Then you are asked to say that in the reaction above, identify what is oxidized and what is reduced. So this causes us to know about what? Oxidation loss. Now, before we talk about oxidation loss, we need also to answer this question first. As we can see here, when we start talking about oxidation loss, we will talk about elements in its normal state. Its oxidation number is 0. And here from 0, it has been oxidized to what? To 2. So we can see an increase from 0 to 2. So we can say that zinc is what? Oxidized. It is oxidized. Then from copper 2 ion, it has an oxidation number of 2. Here we have 0, meaning this one has what? Has been reduced. Copper 2 has been what? Has been reduced. So the two reactions happening at the same time. Oxidation and what? And reduction happening at the same time. So these two reactions happen what? At the same time. So what are some of the rules you need to know for signing oxidation numbers? Very important. With these rules, you need to pay much attention. We say rules for assigning oxidation numbers. What you need to know, rule number 1, all monatomic ion so the oxidation number of monatomic ions is equal to what? Its ionic charge. So all monatomic ions like hydrogen ion like iodide ion, let's say for example barium ion. So the oxidation number denoted by N will be equal to, if for hydrogen, it will be what? It will be 1 because we have 1 here. Then what about iodide? It will be -1. What about barium? It will be +2. So this is how you can give what? The oxidation number of an ion in its what? In its atomic state. So what about hydrogen? You need to know also about hydrogen. So in whole compounds, let me talk about hydrogen. The oxidation number of hydrogen in all compound is positive 1, with exceptions. Let's say with exception. With exception of the sparing. With the exception of metal halides. Metal halides. Say metal halides and hydrogen peroxides. Yeah, no. So metal halides like hydrogen bromide, like hydrogen iodide, in this kind of compounds, hydrogen, the oxidation number becomes -1. But in the list of compound like hydrochloric acid, in this it will be what? It will be +1. Sulfuric acid, always what? +1. We even multiply by 2 here, so it will be +2. So these laws you need to know them by heart. Number 3, you need to know, let's talk now about oxygen. What do you need to know about oxygen? The oxidation number of oxygen in all compounds is -2, with an exception of what? Of hydrogen peroxide. So with hydrogen peroxide. So when you see hydrogen peroxide, just know that in this compound, oxygen, the oxidation number for oxygen is what? Is +2. I mean is -1. Also in fluorine, these things you need to know them. In fluorine, the oxidation number will be +1 of oxygen. So what you need to know is that in all compounds, the oxidation number of oxygen is -2, with an exception of these 2 elements. In hydrogen peroxide, in this compound, it has what? It has -1. And in fluorine, it has what? +2. Let's go and talk of number 4. What about neutral compounds? What's the oxidation number of neutral compounds? Actually, what are these neutral compounds? Compounds which are not charged, like sodium chloride. So the oxidation number of sodium chloride, it is in its neutral state. It's not charged. You can't see any charge. Neither is it negative or positive. So the oxidation number for any neutral compound is 0. Also, same as the oxidation number of any element. If an element is not charged, be it sodium, be it aluminium, all the oxidation number of these elements is 0. What do you need to know? We talked about monoatomic. Let me talk about rule number 6. What about polyatomic? What about polyatomic ions? Also, polyatomic ions, the oxidation number will be equal to the charge. Let's say, for example, we talk of phosphates, because phosphates says to the power -3. So the oxidation number of phosphate, this is a polyatomic what? It is a polyatomic ion. So the oxidation number will be -3. What if we talk of nitrate ion? The oxidation number will be equivalent to what? To the charge. It will be -1. So these are laws that we use for assigning what? Oxidation number. So now let's try to practice more exam questions so that you may be able to put the theory into practice. Let's do examples for better understanding. Example number 1. Say find the oxidation number of sulfur in sulfur dioxide. Okay, how can you find this? First of all, we know that sulfur dioxide is what? Is a neutral compound. So the oxidation number for sulfur dioxide is 0. We say sulfur dioxide is 0. What about oxygen? Oxygen in all compounds, except for fluorine and hydrogen peroxide, the rest of the compound is -2. So oxygen will be -2. So we are looking for sulfur, is what we don't know. So what we do, since this is a compound and it is equal to 0, we are going to split this. We say S plus oxygen, we have 2. We have 2 atoms of oxygen. So we are going to say 2 oxygen then is equal to 0. Sulfur we don't know, but oxygen we know that it's -2 equal to 0. So our S will be equal to 2 times -2 is -4 equal to 0. Then S will be what? This will go to the other side, it will be 4. So the oxidation number for sulfur is +4. Very simple. Now, let's do another example. Let's do another example. What if you have been asked now to find, we say the question is in question 2, say find the oxidation number. Find the oxidation number of chromium in potassium chlorate, like this. So the first thing you need to know, you are asked to find this. What you need to know is that if a metal is found in a compound, it is in the compound. It is its oxidation number is equal to what? To the group or to its valence. So the oxidation number for potassium will be +1 because it is in group 1. Its valence is 1. Chromium is the one we are looking for. We actually don't know. What about oxygen? Oxygen in all compounds, we know it's -2, and the compound itself, it is in its neutral state, so it is 0. So we make a simple equation to say we have 2 atoms of potassium, 2 atoms of chromium, and 7 atoms of what? Oxygen. We equate to 0. This, we have +1 plus 2 chromium, we don't know. Oxygen is -2 is equal to 0. 2 plus 2 chromium, 2 times -7, and 7 times -2, we have -14 is equal to 0. So we have 2 chromium, 2 plus -4, we are going to have -12 to be equal to 0. So our chromium, this will go to the other side, it will be +12. When we divide by 2, we get to have chromium to be +6. So we are even going to say the oxidation number of chromium is what? Is +6. So this is how simple you can what? You can find oxidation number in any compound. Let's try now to do another type of question. So here is another question. In the reaction below, which element is oxidized and which one is what? Is reduced. So if you are asked this kind of a question, actually the reaction is between nitric acid and hydrogen sulfides, producing nitrogen monoxide and water and sulfur. So when you asked this kind of a question, you have to find the element which is oxidized and which one is reduced. So what you need to know is that they are asking about elements in the equation apart from what? Apart from oxygen and hydrogen. Okay, so the elements we are going to look at is sulfur. We are going to talk about, actually what they want us is to talk about sulfur and nitrogen. So let's try to talk about sulfur. Let's talk about sulfur. So to find if sulfur in this, we are going to compare sulfur here and here. So let's talk about the oxidation number of sulfur to the product side, to the reactant sides. To the reactant side. So sulfur is in this. To find the oxidation number, we are going to say 3 times 2, meaning we have 6 of hydrogen. Then we have 3 of what? Of sulfur. 3 atoms of sulfur. Where we are going to equate this to 0. Hydrogen in any compound is +1. So this one, even if we multiply, it's going to be 6. And 3. S is equal to 0. Taking that to the other side, we are going to have a negative, so we have S to be -6, dividing by 3. So sulfur is what? Is -2. The oxidation number for sulfur, we say even the oxidation number for sulfur is -2. What about the product sides? It is in what? It is in its element. It is in its elemental form. So when an element it is in its atomic state, its oxidation number is actually 0. So to the product sides, the oxidation number for sulfur is 0. So we can see from negative to 0, meaning negative is smaller than what? Than 0, meaning sulfur, you even say sulfur is what? Is oxidized. Let's now talk about nitrogen. Nitrogen is in this compound. You need to show. So, let me lab the space here. Lab. So here are reactants. So we have in this compound, okay? We need to know the oxidation number of nitrogen in this compound. Actually, this is hydrogen, like this. So we say we have 2 atoms of nitrogen. Why am I getting confused? It's hydrogen. Then we have also 2 of nitrogen, because we are multiplying by these 2. Then oxygen we have 3 times this, meaning we have 6 of oxygen. We equate to 0. Nitrogen we don't know. Hydrogen in any compound. Okay, let me treat this to be nitrogen because I started making the same mistake from the beginning. So this one becomes the hydrogen. So hydrogen, we know that it's positive 1. Then oxygen is negative 1. Negative 2. We even equate to 0. We do. So we say 2n. 2 times 1 is 2. 6 times negative 2 is negative 12. Is equal to 0. 2n. Negative 12. We are having negative 10. Is equal to 0. Negative 10, when it's crossed the other side, it will be positive 10. We divide both sides. We have 10 like this. We divide both sides by 2. We are having n to be positive 5. So to the reactants, the oxidation number of nitrogen is positive 5. What about to the what? What about to the products? To the product, we have 2n plus 2 oxygen. We equate to 0. 2n, we know oxygen is actually negative 2. Is equal to 0. When it goes to the... Okay, we first multiply out. I'm very fast. To become 0, 2n. Then once it's crossed the equal sign, it becomes positive 4. We divide by 2, we divide by 2. We are having nitrogen here to be what? To be positive 2. So now we can tell to the reactant we had 5, to the product we have 2. So we can see that this number has been reduced. So we can say that nitrogen is reduced. Very simple. So this is how you can answer this question. You show also through what? Through calculation, like the same way I was representing my work here. So let's do another question. So you have been given the compound, which is potassium permanganate. Then you are asked to assign the oxidation number of manganese to what? In this compound. So what you do, we know that this is in what? It is in its neutral state, so its oxidation number is actually 0. So we are going to add that of potassium, manganese, and oxygen. We have 4 atoms of oxygen. We equate to 0. Potassium in all compounds, it is positive 1. Manganese is the one we are looking for. Oxygen in all compound except with hydrogen peroxide. It is actually -2, even equates to 0. So 1 plus Mn. 4 times -2 is -8. It's equal to 0. What we do, 1 plus -8, Mn to be -7 is equal to 0. Crossing the equal sign, it becomes +7. So even conclude to say the oxidation number of manganese in this compound is actually +7. Very simple questions. So question 5, is this reaction a redox reaction? We've been given a reaction between magnesium and oxygen to produce magnesium oxide. The reaction is already balanced. So now, to know if a reaction is a redox reaction or not, you need first to assign oxidation number to both products and the reactants. So now, if you find that the oxidation number of an element has changed, then that one, that kind of a reaction is what is an oxidation reaction. Now, if there is nothing changing, both reactants, the oxidation number of all the reactants are not changing, then that reaction is not what is not a redox reaction. So to find if this reaction is a redox reaction, we need to know the oxidation number of magnesium. So we can see that oxidation number, it is magnesium is in its atomic state. So the oxidation number here is 0. What about oxygen? Oxygen is also in its atomic state, so its oxidation number is also 0. Let's talk about now to this side. The oxidation number of oxygen in any compound is -2. So let's find the oxidation number of what? Of magnesium. So we know that we are going to do this. We say 2M plus 2 oxygen. Then since this is a neutral state, it's not charged, it's not charged, then it will be equal to 0. So magnesium is the one we are looking for, actually Mg here. Then oxygen in any compound is -2, equal to 0. Two times -2 is -4. When it's go to the other side, it will be +4. We divide by 2. So magnesium, the oxidation number of magnesium is actually +2 to the reactant. So we can see that there is a change. Magnesium has been oxidized from 0 to +2, and oxygen has been reduced from 0 to what? To -2. So you can say that hence the reaction is what? Is a redox reaction. So to find if it's a redox reaction, it's like they are just asking you to calculate the oxidation number. You assign oxidation number to all the elements in the reaction. Then you compare if there is a change in their oxidation number. So if there is a change like the one we have seen here, you are going to say that the oxidation number and the reaction is a redox. If it's not, then it's the opposite. It's not what? A redox reaction. So let's do another question on the same thing. So another question, is this reaction a redox reaction? So we are doing the same thing. We are going to assign oxidation number of each element. We start from the reactants. Let's talk of hydrogen. Hydrogen here, the oxidation number of hydrogen. Let's talk of hydrogen first. How many hydrogens do we have? Here we have +1 because it is in a compound. It is also here +1. So the oxidation number of hydrogen is actually +2. Let's talk about now the oxidation number of chlorine. To know the oxidation number of chlorine, what we do this. We say hydrogen plus chlorine is equal to 0. Hydrogen is 1, chlorine is the one we are looking for, so chlorine will be, this will go to the other side, it will be -1. So for chlorine we have -1. What about sodium? Sodium in sodium hydroxide, it is also the same. What we do, we say sodium plus oxygen plus hydrogen is equal to 0. Sodium is the one we are looking for. Oxygen in all compound, it's -2. Then hydrogen is 1, say equal to 0. So our sodium here, we have -2 plus 1 is equal to 0. So sodium is equal to -2 plus 1 is -1 is equal to 0. Then when it crosses the equal sign, then our sodium will be positive 1. So here sodium, the oxidation number is +1. So we are done with what? We are done with the reactants. We come to the products. Here we have sodium and chlorine. Whole group 1 elements in a compound is what? Is positive what? It is +1. Okay, so sodium, even here, the oxidation number of sodium is +1. So meaning chlorine, we will say that sodium plus chlorine is equal to 0, where this is 1, here still be 0. So when it's crossed the equal sign, we are going to have -1. So for chlorine, N is -1. Actually, we didn't talk about the rest here. Oxygen here, we didn't talk about oxygen. So oxygen in any compound there, the oxidation number is -2. Very simple. Let's now talk about hydrogen. Hydrogen in any compound is +1, but we have 2 hydrogen here, so hydrogen will be 1 times 2, which will be 2. So it's +2 here. Oxygen in any compound, it is -2. So the oxidation number there is -2. Now our next step is just to compare. We try to compare now the oxidation numbers. So here +2, hydrogen here +2, no change. Chlorine -1, here -1, no change. Sodium +1, no change, no change, no change. So you can even conclude to say it's not a what? A redox reaction. Very simple like this. So now let's move on. Now we talk about how to balance redox reaction. Another important part in chemistry exam, because you find that question to have 8 marks, sometimes 10 marks. The least marks it can hold, it can be only be maybe 7 marks. So let's move on. So guys, before we move on, if you find this video helpful, please consider subscribing to the channel. You give it a like. You also hit the notification button. You share the video so that it may reach other audience. So let's keep watching. Let's go now. I'll be very slow so that you understand this part. It's also very, very important. You can make some mistakes when answering this question, but if you just follow all the steps I'm going to give on how to balance redox reaction, you won't find any difficulties. So let's talk about the steps. The first step, when balancing redox reaction, you need to split what? To split the overall equation into two. You split into two half reactions. The method we are using is a half reaction method. Into two half reactions, of which one should be an oxidation reaction, oxidation half reaction. The other one should be a reduction half reaction. So you are given an equation. You are going to consider which part of the equation is what is being oxidized and which one is what. You split into two equations. You are going to understand this one once we start once we start solving. So what you can do, if you have a notebook, try to take note of the steps. They are very important. Step number 2, you need to balance all atoms. You balance all atoms except oxygen and hydrogen. You say except oxygen and hydrogen. So you balance all the atoms except hydrogen and what? And oxygen. So in an equation, you have been given different kinds of what? You have been given different kinds of atoms which are in what? In that equation, but you can balance them except what? Except oxygen and hydrogen. Now after that, after you balance atoms, the next thing is for you now to balance oxygen. You balance oxygen. How do you balance oxygen? You balance it by adding water. The reason we balance oxygen, we know that in water there is what? An atom of oxygen. So we are going to use this water to what? To balance oxygen. You need to take note of this. Our fourth step, it's now to balance hydrogen. We balance hydrogen. So now how do we balance hydrogen? Hydrogen is balanced in two ways, because balancing redox reaction, some redox reaction will be in basic medium, other will be what? In acidic medium. So those that are in acidic medium, we are going to balance redox reaction. We are going to balance hydrogen by adding hydrogen ion. This is even making sense because the acid produces hydrogen ion. Now for those redox reaction which will be in basic medium, we are going to balance this by adding what? By adding hydroxide ion. Some they make mistake by saying since it's in basic media, let's just start by using acidic media, then we drift at the end. No, that kind of a method is not acceptable, and most of our lectures take that method to be wrong. When you are just dealing with a basic media, just go with the basic method. You just add hydroxide ion to balance what? To balance hydrogen atoms. After that, now you are going to multiply heat half reaction by factors, so that the electrons may balance. So number 5, you say you are going to balance electrons. We are going to balance electrons. So how do we balance electrons? Let's say, for example, to our positive side we have 3 electrons. To the negative side we only have like we have 6 electrons. How are we going to balance this? This means we are going to multiply both, because how are we going to balance the equation 1? Our first half equation is this, our second is this, and this one, in this second we have 6 electrons altogether, and in this first half reaction we have 3. So to make we have to balance electrons, what we do to our first equation, what are we going to do? We are going to multiply it by what? By 2. So our first equation will be multiplied by 2, so that we may also have what? 6 electrons. This is what we do. After that, you are now going to cancel out common species. Some they had. You can add half reactions. And now you cancel out. You cancel out common species. So this question is very important. You need to know all these steps one by one. After now you do that, what are you going to do next? If your solution is basic, you are going to convert hydrogen to hydroxide ion. Actually, and I've explained that already. Your last step is just now to check. You check if atoms now have balanced. Check atoms if have balanced by assigning redox reaction. That one, this step you can use it for what? For proof, more especially in exam. You don't even to show it if you don't have time. You can hand here after you just cancel out, then you write the what? The net ionic what? Ionic equation, which is our last. I'll write it here. H, you write now the net ionic equation. Then if you have time, you can check now if both their atoms are balancing. It is not recommended, for proving sake, if your work is what? Is correct. So now let's do questions. One will be on acidic media and the other one will be on basic media, so that you have practical information. So this is the question. You may likely to find in an exam, the tests. Actually, may not be asked to solve this question in your quizzes. So the question reads: balance the following equation in acidic medium. You have been given copper 2 sulfide plus nitrate ion producing copper 2 ion plus sulfate ion and nitrogen monoxide gas. So we split our first step. As for me, I'll be writing for you to say at a certain level, we say step 1, but you don't need to show this. Step 1, we're going to split this, into half reactions. So the oxidation half reaction. So what I used to do without wasting much of time, I can only say that this is related to copper and what? Sulfates. Okay, and you see that this copper has been oxidized from 0 actually to what? To 2. Okay, based on oxidation what? An oxidation reaction. Or if you want to do this, you can prove by doing what we were doing there on assigning oxidation number. Here I'm not going to show you, but when you are answering, you have to show. So we say it is in solid state, it's going to produce what? Plus then the reduction reaction. This is the half method reaction. So it's this and this. You say nitrate ion producing nitrogen monoxide gas. Very simple like that. What do you do next now? What is our next step? Our next step now is to balance atoms other than what? Other than we say we balance atoms. We balance atoms except hydrogen and what and oxygen. So we can talk of copper in our first. So copper and sulfur, I think copper and sulfur are already balanced. We only have one each. Okay? We only have one here, also here one, even sulfur, even here one. So it is already balanced. So we skip this step. Let's now balance oxygen. Our step 3. We balance oxygen. So this is our first. So to balance oxygen, we are saying that we are going to add water. Okay. So in this we have how many oxygen? We have 4. Okay. So if we add water to the side where there is no oxygen here, H2O, meaning we are going to have 1 oxygen, 4 water. So to balance, we are going to say we're going to add 4 molecules of water so that we may have 4 oxygen here, or as we have to the product side we are at 4 oxygen. So let me scroll down a bit. Yeah. So we are saying we are adding 4 molecules of water to produce plus sulfate. So you can even tell to say we have 4 oxygen also here. 4 oxygen, 4 times 1 here we have 4. What about in our reduction reaction? Reduction reaction, we have how many oxygen here? We have 3. Here we have how many? We have 1. So what we do is we are going to add 2 molecules of water so that here, because what you need to see is this: here we have 3 oxygen, here we have 1 oxygen, so we are lacking 2 oxygen. So to have 2 oxygen, you have to add 2 molecules of water to the side which is lacking. So we say is producing what? Nitrogen monoxide plus 2 molecules of oxygen. So from this we can tell that here we have 2 plus this one 3. So is what? To the left hand side, which is the reactant side. What is now our fourth step is now to balance hydrogen. Our step 4 now. Let's balance. Here we are balancing oxygen, here we balance hydrogen. So how do we balance hydrogen? We are going to count How many hydrogen atoms we have here? We have 4 times 2, we have 8. And here we don't have any, so we are going to add 8 hydrogen ion so that we may balance. Then we add 8 hydrogen what? Ions. From this now you can tell to say that hydrogen has also been balanced. Oxygen has also been what? Been balanced. So what we do next? It is in our second half reaction. Here we have 2 times 2, we have 4. Here we have 0, so we are going to add 4 hydrogen ions to the reactant side. We say nitrate ion plus 4 hydrogen ion. Then to produce nitrogen monoxide, then plus 2 molecules of what? Of water. This is what? This is now our fourth step. So you have to follow these steps one by one. You are even attentive. So in an exam that can make you feel style. So you should be practicing this question until you get familiarized yourself with answering it at a very high speed. Because you may know, but if you don't know how to use time, it's work done equal to 0. So step 5. Step 5 now, we are going to balance charges or electrons. Okay, we are going to balance electrons. So how do we balance electrons? So in this reaction, how many electrons here do we have? To this side we have no any charged what? Any charged particle, so we have 0 here electrons. But here we have how many? Positive ones. Positive ones we have 2. We also have 1 times 8, which is 8. So positive we have 10. And negatives we have 2 electrons which are negative. So the overall electrons we have 8 what? 8 electrons. So to balance this, we need to have both sides be equal. So we are going to add electrons here to this side, which are what? 8, so that we have both sides to be what? To be 0. This is what we do. So our first reaction would be plus 4H2O plus 8 what? 8 electrons. From doing this, you can even say that these electrons, 8 electrons, 8 hydrogen electrons, and these electrons will cancel out because electrons are negative. So it will cancel with this positive 8, and this 2 and positive 2 will cancel. Same as it will remain also. It will this part will become like uncharged, just like this part, the way it is in neutral what? Reaction. So we balance this kind of a reaction. Let's now balance the second half reaction. What do we have here? Here, no charges. So we are going to look to this side. We have how many? We have 1 which is negative, and positive we have 4 because we have positive 1 times this, which is 4. Positive 4. So the overall charge here, it is positive what? Positive 3. So to balance, we are going to add positive what? we are going to add 3 electrons here to this side because the overall is positive. What we want to do here is to cancel electrons, okay? So if the overall is positive, the electrons will be added to that side because the electrons are negative, so that we may cancel this negative, this positive. Now, if the whole value is negative, we can't add to the negative, to the part where what the whole value is negative. We're going to add to the what, to the other part. Okay, we're going to add the electron to the other part, so that here we have 1. Also here we have 1, so that these things balance. So I think now, since I've explained that you cannot ask a question why we added 8 electrons here instead of adding here, because the whole value was positive, so we have to add here electrons. Even here the whole value is positive 3, so electrons we are going to add here. So what we will do, we will say this: nitrate ion plus hydrogen ion plus, we have 3 electrons. Electrons are always negative, so to produce nitrogen monoxide plus 2 molecules of water. This is now what you do. Our next step, step 6, is to balance electrons. You need to follow these things, guys. It's nothing difficult here. It's only following things step by step. So what we are doing is this now. Our step 5. I'm sure it's step 6 now. You balance electrons. You balance electrons. So how do we balance electrons? Here in this we had 8 electrons in the oxidation half reaction. We have how many? 8 electrons. Now, in this other, we have what? In the reduction, we have 3 electrons. How are we going to balance electrons? So what we do is this. Let me say, for example, you have been given 3 and 5. How can we make these numbers to be equal? We have to multiply 3 by 5. Also, we multiply 5 by 3. So that 3 by 5, it will be 15. Also, 3 by 15. 3 by 3, it will be what? 15 also. This is how we balance. So what we are going to do is that we are going to multiply the whole equation, our whole first equation, by 3, so that we may balance these electrons, so that also this equation, which have 3 electrons, is going to be multiplied by 8. So we start. 2 multiplied by this, you are going to have 2. 2 times here, sure, we had 4 here, so we are going to have, actually we are multiplying by 3, I'm sorry, multiplying by 3. So 4 times there, we are going to have 12 H2O. These things are very simple. You multiply there, you have 2, 3, why 2 in at my lips. Then there we have 3. You now know what is happening here. You can't get confused. H times 3 is actually 24. 24 hydrogen ion. And electrons will be now also 24, because we are multiplying by 3 the whole equation. We say 24 electrons. Now, this other equation we multiply by what? By 8. So, our equation, this times 8, we have 8 nitrate ion. 8 nitrate ion. H times 4, we have H2. Of H2 hydrogen ion. Oh, we also have also electrons here. Let's multiply out. What do we do next? 8 times 3, it's 24. Then 8 times this, you have 8. Hydrogen dioxide here. 8 times 2 is 16. Okay. So now you can even see that we had 24 electrons also here, 24 electrons. So this is all about this step. What about our next step now? Our next step, at this step now, we are going to cancel out. Okay? Before we had, I like cancelling out first. Then we find the net ionic. So step 5, actually step 7, we cancel out. Okay, so electrons and electrons will go. What else do we have? What else do we have? We have how many? Okay, let's do step 5, step 7. I don't want to confuse you. Let's write now the let me lab on top here. So what I want you to understand is this. Since we have now cancelled electrons, because electrons are equal, we balance them, then we cancelled them. What are we going to do next is now to combine what? To combine the two reactions, which is step 8. Very simple. So we'll start with this. We say 3 copper sulfide plus 12 H2O. What else do we have here? In the other equation, we have remained with this and this, which is 8 nitric acid plus H2 hydrogen ion. That is to our reactant side. We had now this side. This side we have this part. We said 3 plus also 3, actually sulfate ion plus 24 hydrogen ion plus, what else do we have here? We had now here H nitrogen dioxide, actually nitrogen monoxide. Then we have 16 here. Like this, molecules of water. So now what we do next, since we've now had it, we are going to cancel out what we want to write. It's now the net ionic equation, which is our step 8, our step 9, the net ionic equation. So what we do next, we are going to see here we have H2O. We also here we have what? H2O. So what we do is we are going to subtract. Since here we have we are going to cancel here 12, also here 12, and we are going to remain with how many? If we subtract 16 minus 12, we are going to remain with 4. So we are going to remain with 4 H2O here. 4 H2O here. What else do we have in common? We have hydrogen ions. EFH2, here we have 24. So we are going to cancel here 24. We subtract from H2, we remain with 8. Hydrogen what? Hydrogen ion. So what do we do next now? It's just to write the remaining. It is what we are calling to be the net ionic equation. By doing so, then you are done. So we say copper sulfate is solid plus 8 so else we've remained with here plus we remained with 8 here, hydrogen, so we say 8 hydrogen ions. This is in aqueous, this is also in aqueous. What have we remained with here? We've remained with actually 3 copper 2 ion, remained with 3 H nitrogen dioxide, and 4 molecules of water. It is in liquid state, here in gaseous state, here in aqueous state. So after doing that, then we are done with what? With a net what? Ionic equation. So it is a long process, but very simple once you just know the all steps which I aforementioned when I was teaching on how to go about this. So if you want to check, you have time to check, you can start checking. 3 of copper, even here 3. Sulfate, we have 3, even here 3. What about oxygen? 8 times the 3, we have 24. Here we have 3 times here, it's 12. Plus here, 8. Plus here we have 4. 8 times plus 12 is 20. Plus 4 is 24. So all our T are balanced. So this is now our final answer. Very interesting topic. That's why I said it carries 8 marks, sometimes 10 marks. So be serious with what? With these things. They are very, very important. So now let's do a question on balancing redox reaction in basic media. So we have been asked to balance this kind of an equation. So our first thing is to identify the half reaction, the one which is oxidizing and the reduction one. And in this one, I'm going to show you how you can tell this is the reduction half reaction. We know that this one is going with what? With this one. Okay. But we know that this is in what? In heat. This one is in in its neutral state, so the oxidation number is 0. And all polyatomic ions, okay, the oxidation number is equal to the charge, so this is -1. So we can tell that this is what? An oxidation what? An oxidation reaction. I mean, this is the what? This is an oxidation, yes, because -1 is smaller than 0. So an oxidation 1, this is actually our step 1. Meaning the reduction one would be that one, the reduction of reaction would be so our second step now is to balance atoms rather than what? Rather than oxygen and hydrogen. So this will be our second step. We are balancing. So in this we have manganese. It's 1 and 1 balanced, so we can write it down here. We can write it down here as already balanced. We say it is already balanced. Then this one carbon, here we have 1, here we have 2, here we have 1, so I'm going to put 2 here. Say 2 carbonic ion. So this is a carbonate ion. So now we have balanced carbon dioxide. Our next step now is to balance oxygen. How do we balance oxygen? Here we have 4 atoms of oxygen, here we have 2. So we are going to add here. We are going to add here how many? We are going to add 2 molecules of water, so that we have 2. We have 4, even here 4. What about here? How many oxygen do we have? Here we have how many? We have 4. Here we have 2 times 3, which is 6. So to make it 6 here, we are going to add 2. We have 6 here. Here we have how many? We have 4. So I have to add 2 molecules of water, so that we may have how many? In this case, we have hydrogen what? Being balanced. So our third step now is to balance what? To balance hydrogen. So we are going to balance hydrogen by adding what? By adding hydroxide ion. So you can now ask here, how many hydrogen ions do we have here? We have 4 hydrogen ion, and here we don't have any hydrogen ion. So we are going to add 4 hydroxide ion. 4 hydroxide ion. So we had 4 hydroxide ion here. What about here? We have how many hydrogen ions? We have 4 hydrogen ions. We have 4, so even there we are going to add 4 hydroxide ion. We're going to add 4 hydroxide ion to that side. So like this. So in basic media, don't make a mistake to go by acidic medium, then you drift at the end. That method is not is not recommended. After doing this now, what else are we going to do? Is to balance is to balance electrons. So let's try now to balance electrons. So now what we're going to do next, as you can see here, we have how many electrons here? So here we have 4 negatives. In this equation we have 4, and both are negative, so the overall is just negative 4, and here we have 0. So what we do, since the overall is negative, we are going to add here 4 electrons like this, so that we balance it 4 electrons here. What about here? Here we have how many electrons? Here we only have 2, which is negative, and here we have how many? We actually have also 2. Yeah, exactly, we have 2 also. So now here we have 2 times this 2, we have 4. So to balance this, we are going to add 2 electrons here, so that to both sides we have -2 plus 2, we have -4. Even here we have what? -4. So after doing this, now what we are going to do next is to balance this these electrons. So what you do next now, so you, when you are answering, you should be following step by step, like the same way I'm trying to explain there. So that's why you are seeing from the next step, and the second step I'm answering from from the same step. So what you do next, we have 2 electrons, we have 4 electrons. To balance 4, we have to multiply this by 2, the whole equation by 2, so that this one may become 4. So the first equation will just remain the same. We're going to have 4 hydroxides plus manganese oxides, dioxide, then plus 4 electrons. Now once we start multiplying by 2, this one is going to become 4 electrons. Then this 2 times that, you're going to have 4. Then 2 times this, you're going to have 2. These things are very simple. 2 times this, you have 4. Plus 2 times that, so we have 4. Also H2O. So now electrons can cancel out. What we do next is just to add the two reactions. Okay. So in the first reaction we have hydroxide then we follow by adding this, we are to the reactant sides. Okay. Then we come to the product side. plus then this. Now let's talk about this. This is also a water molecule. This is also a water molecule. So we can add them. We have 6 water molecules. Yeah. So our last step now is to cancel out those that are appearing what? And we need to have hydroxide here. And something missing here. Okay. Let me look. When we were balancing hydroxide, I think the mistake is here. Let me try to change the color. Okay, so the mistake was here. In this equation, we balance hydroxide ion. So now, if in this equation we didn't indicate where we balanced what hydrogen ions, because we had 4 hydrogen ions, so we're supposed to add here. We're supposed to add for what? We're supposed to add 2 hydroxide ion to what? To make it what? Equal. So we are going to do this question again. Okay. And I'll be a little bit faster since you know everything now. We are going to be faster. So let's now go through it again first. So this was the equation we asked to balance in basic media. So the oxidation and the reduction of reactions are these. So now our second step is to balance atoms except oxygen and hydrogen. So we know this is already balanced, and you only have to balance what? Carbon. We have 2, we have 1 here. Want to see where we made a mistake. So our next step now, after we do this, is to balance oxygen. Let's balance oxygen. So we balance oxygen by adding water. Here we have 4 molecules of oxygen. Here we have 2. So we are going to add 2 molecules of water. Plus 2 molecules of water, H2O. Then here we have 4 molecules of oxygen, and here we have 6. So we are going to add 2 here, 2 molecules of oxygen, so that we may make 6. We say plus 2 molecules of water, so that we may have an equal equation, an equal balanced reaction. So once we reach here, what? Oh, it's not water. I think it's where I made a mistake also here. It's carbonate ion. 2 carbonate ions there. So 2 carbonate ion. Yeah. Now once we reach here, we balance the oxygen. So what else is to balance the hydrogen ion? So hydrogen ion, we have 4 here. So we are going to add 4 hydroxide ion here. Because in basic medium we had hydroxide ion, not hydrogen ion. So we are going to add 4. 4 hydroxide ion. What about here? We have 4. So here we are also going to add 4 hydroxide ion, like this. Now, once we reach here, we are going to balance electrons. To balance electrons, what we do, here we have how many electrons? We have, this is 4, this is 1, so we have 5 electrons here, which are actually negative. So we are going to add here 5 electrons, like this. So these are some of the mistakes we made there. So what do we do next here? We have how many electrons here? We only have 2 electrons. What about here? We have 4. We also have 5. So here 2 times 2, it is 4. Since both are negatives, even 4 times this one, it is also 4. So we have 8 electrons. Yes, 8 electrons, which are both negatives. So our whole value is negative electrons. So since the whole value is negative, we are going to put here 6 electrons. Why 6 electrons? So that we can make it 8 here, so that we can balance with 8, which is here, because we already have 2. We also have 2 here, so that 2 plus 6 we have 8. Here we also have negative 8. So now that we balance electrons, here we have 5. We have 5 electrons, here we have 8 electrons. How are we going to balance? So to balance these electrons, now we are going to multiply. Here we have the whole value of 8. How many electrons do we have? Here we have 6. Yes, the electron we have 6. Here we have 5. So we are going to exchange. This is going to be multiplied by 6. This one is going to be multiplied by what? By 5. So if we started multiplying 6 times 4, we are having 24 hydroxide ion, then 6 to produce 6 also. 6 times 2, we have 12. Then 6 plus 5, we have 30. Yeah, we have 30 now. Let me scroll up. So we had the 30 electrons. The 30 electrons. So now we start multiplying by 5. 5 times 5, we have 30 electrons. 5 plus 5 times 2, we have 10 H2O. To produce 5 times this, we have 5. We also have 10 here, because when we multiply 2 by 5, we have what? We have 10. So as you can see now, 30 and 30 are what? Are equal. So these are going to what? To cancel out. Our fourth step is now to add these reactions. So what are we going to do? We are going to do? here we've forgotten to multiply 5 times 4 hydroxide so that we may have 20 hydroxide ion. Yeah. So now once we reach here, we are going to add this reaction. So we start by adding the reactants. So we are going to have 20, actually 24 hydroxide, 6. Then you add plus 10 H2O. Then we come to the reactant side. We have 6 now you can see this. This and this. This and this are one and the same. So what we can do, we can just say 6 plus 5. It is actually what? 11. So this is actually not part of this half reaction. It was in this half reaction. So it was just a mistake. We removed this one. So it's just 6 plus 12 H2O plus now 10 then 20 hydroxide ion. So what we do next now is just to leave this into a reduced form, the net ionic equation. So we have 24. Here we have 20. So this one will cancel. Also here cancel, we will remain with 4. What else do we have in common? We have 10. We also have 12. So this one will cancel, also cancel, we will remain with 2H2O. So now we can write down the net ionic. Which is 5 I'm having problem with my pen. We also have this 4 hydroxide, we shouldn't forget. 4 hydroxides, then producing we have 10 plus 2H2O. Actually, this is our what? Our net ionic equation. So guys, if you found this video helpful, please consider subscribing to the channel. Don't forget to share the video. See you in the next lecture. If you missed the previous lecture, I'll share the link in the description section, so try to check it. See you in the next video.